Welcome to this virtual house tour as part of Sustainable House Day 2024. My name's Harley Truong and I'll be presenting the Rodway Passive House Part 1. There's another part to this video, but it will only be released in 2025. The house is located in Yarralumla, Canberra, and I'd like to acknowledge the traditional custodians of the land, the Ngunnawal and the Ngambri people. This is me and my family, our dog, and our passive house in Chifley. You may have heard or visited this house on previous Sustainable House Day tours. This is my mum. She's 88 years old and lives in this 1980s house. These are my in-laws. They're in their 70s and live in this 1960s house. So here's my grand plan. You see, at the moment, my extended family lives apart and we pay separate water bills, energy bills and rates. What if we could all move in together and live in one nice big house? It makes good financial sense, but it's also for the greater good because it frees up all of our old houses for other families to occupy. 2 years ago, I found this house for sale, a 1950s weatherboard house in fair condition and with modern colours, but it had termites, and lots of them, and they were still alive. The location was ideal in a quiet, leafy street, and the orientation was perfect, with north along the long axis and the front of the house facing west but shielded by street trees. We employed local Canberra architect Michael Tolhurst from Envelope Architecture to design our house. Now Michael designed this passive house in Narrabundah, which is also open on the Sustainable House Day tour this year. We employed Kieran Mansfield from Craft Building to build our house. This is Kieran's first passive house in Murrumbateman, and this is his second in O'Connor. The architectural brief was simple. We wanted a house for 7, but with just enough private and communal space. It had to support ageing in place with barrier-free entries, wide hallways, and it had to be all electric with heat pump hot water, heat pump heating and cooling, and induction cooking. And the most important thing was that it had to be designed, built and certified to the Passive House standard. So here's the final floor plan. This is the ground floor, and here's space for my in-laws, here's the space for my mum and for my family downstairs. Upstairs there's 3 bedrooms and 2 bathrooms, and overall the house has 340 square metres of living space plus a 50 square metre garage. Sounds like a lot, but it only works out to 50 square metres per person. And we've left enough room for some medium to large trees, not just because it was a requirement of the planning approval, but trees just look nice. Here are renders of the front of the house facing west, the side of the house facing south, and the side of the house facing north. And when we peel back the layers on this 3D model, you can see how the house is made. The advantage of having a full 3D elemental model is that you can use it to generate material takeoffs. So this table here was generated and given to the builder, letting him know how much timber we needed. And the second advantage of a 3D model is that you can simulate the path of the sun to see exactly how much solar gain you're going to get in winter. Looks like I'm going to get about 4 meters of penetration. And in summer, it looks like the sun won't enter the room except for a tiny corner in the morning. The house was modelled in the Passive House planning package. Here is the summary sheet. And here it says that the heating demand is 9 kilowatt hours per square metre per year. As long as it's below 15, then we're all good. The house was also modelled in Nathurst and we got 8.4 stars. So at the end of 2023, the fence went up and the house was marked for demolition. But before that, I managed to sell all of these appliances on Gumtree and the roller door, and I removed the air conditioning unit to use later, and I did pay a fridgie to cap off the refrigerant. There was so much bonded asbestos that it nearly filled the skip, and we paid the demolition crew a little bit extra to salvage all the hardwood timbers in this house. Here you can see how they separated the salvage materials for recycling. This is the pile of timber that we were left with. It's mixed ash and had tons of nails in it. It took ages to remove 1,500 nails. But it was worth it because we took it to Thor's Hammer, a local timber recycler, who then cleaned it up and turned it into this: ceiling lining boards. So now that the old house is gone, you can see that the block is almost flat, which makes it very easy to build on, except that the soil engineer came back with a rating of a H1, which means it's a highly reactive site and we need additional piers to stabilise the slab. Normally with board piers, you drill a big hole 350 millimeters in diameter down until you hit solid ground, and then you fill it with concrete. But instead we use katana screw piles, which are made of steel and are literally screwed into the ground. We used 66 of them. Doesn't look like much when it's finished, but the site was left clean, and if it rained, there was no issue with water filling up holes before concrete was poured. We went with a biax slab, which is similar to a waffle pod slab, but the main difference is there's no foam. The pods are made of recycled plastic. Here are some images of the slab pour. We chose eco-packed concrete from Holcim because it has fly ash content that reduces the carbon emissions by up to 60%. Let's do the maths. We used 75 cubic meters of concrete for the slab, and it came in 15 concrete trucks, and it was equivalent to emitting 15 tons of carbon dioxide into the atmosphere. But that is the same amount of carbon emitted when you fly 2 people from Sydney to London, return economy class. Maybe we shouldn't focus so much on the carbon emissions of building a house and focus more on our air travel. And fast forward to the present day, this is where we're up to on site. I hope to see you on the tour, and keep an eye out for next year's part 2 video.